In this video, I'm going to talk about how we can use NumPy to do some vector geometry calculations. We're not going to use SymPy for this at all. I'm not even sure if that's possible, but I think there probably is some built-in functionality in SymPy to do vector geometry. We mainly want vector geometry for least squares regression, which is very much an applied type problem, which you would naturally want to use NumPy for. So let's import what we need. And we're going to work with these two vectors that I've defined here, v and w. And it's easiest just to enter these vectors as row vectors. It's easier to type them that way, right? Because you don't have to, if you think about it, you don't have to type as many square bracket symbols. And it also just works better in NumPy. And so I'm going to enter these as row vectors, and I'm going to look at them and confirm that this is what I want. So I've entered these two vectors as row vectors. To find the dot product, the command is mp.dot. And notice that I get this weird looking output. So the answer is -10. You can confirm this on your own just by taking the dot product of these. It tells us not just that it's -10, but it tells us that it's recorded as a floating point decimal, which is not something that we necessarily want. And so if we add in the print function, it will just tell us the number. Just something to keep in mind if you're getting outputs that you don't like the look of. We can also find the norm of a vector, so the length of it. So the length of v is 3.74 in this case. And again, we got if we wanted to get rid of this np.float 64 part, we could just print this out. So we've found a dot product. We have found a norm or length of a vector. What about the angle between two vectors? Well, there isn't, to my knowledge, a built-in function for the angle between two vectors, but we can make it work, right? So we can figure out that the cosine of the angle is the dot product divided by the product of the norms in parentheses. And then using the arc cosine function, I can figure out what the angle is. So here we can see that the angle between these two vectors in radians is 1.9. Now, this video was going to be really short. I was going to stop right here. But then I realized it's a good opportunity to introduce just a little bit to those who are unfamiliar with it, or for those who are more familiar with coding. When I start doing something like this, I realize, look, if I'm going to find a lot of angles between vectors, I should really just write a function that does this so that each time I don't have to retype this code. And so I'm going to write a function that's going to find the angle between two vectors. So it's going to be called angle, and it has two inputs, v and w. And whatever I put in the input, it's going to do exactly what I did up here with, and it's going to return whatever the angle was. Now, I'll point out for those who are going to be sticklers about this, this is really bad practice. My function probably should have some feature where if what you input aren't two vectors of the same length, it will spit out an error message, right? If I were going to actually try to provide this like as part of built-in code to something, if someone typed in just like a number instead of a vector, or if someone typed in a vector of length 3 and a vector of length 4, I should have an error message built in. I'm not doing that. I'm just doing this for our own purposes. And so, be cautious. You'll probably get an error message if you type in wrong things, but it might not be what you want. So I'll run it, and nothing's going to happen because all I did was define the function. But now when I run that function, angle between v and w, it gives me the correct answer. And so this is nice because now if I have a bunch of different vectors, I don't have to retype everything or copy and paste everything. I can just reuse this angle function. All right, so we could do a lot more things, but there's one more natural thing to look at, is projecting a vector onto another vector. And again, I want to write a function to do this because why not? And this introduces maybe a little more caution about functions. I already mentioned that we really should have error messages. I want to figure out how to project v onto w, or I'll define it in terms of u and v. And I added this comment to my code that this function outputs the projection of u onto v, because with the angle function, it doesn't matter which vector is which. the angle between two vectors is the same no matter which order you put them in. But projecting u onto v is not the same as projecting v onto u. And so it's not obvious, if I just defined this function without the comment, which vector you should write first. Are you writing the vector that you're projecting first or the vector that you're projecting onto first? And so I added a comment to avoid that ambiguity. And if we're projecting u onto v, what we're going to do is we're going to take the dot product. We're going to divide that by the length of v squared. And we're going to multiply by v. And we'll return that as our answer. So I'm going to run this to define the function. And I defined it in terms of u and v. And so this will take just any two outputs and do all of this with it. But I want to project my vector v onto w. So I'm going to type in projection of v onto w, and I'm going to click play. And this gives me as an output the projection of v onto w. I would hesitate to be overly reliant on this code, right? Projecting a vector onto another vector is not a hard thing to do by hand, and it's something you should be aware of how to do by hand. I was more pointing this out since it was already a short video as a way of introducing, for those who are a little unfamiliar with it, or for those who have seen some of it, that we can take what we've been doing, a lot of using Python kind of just as a calculator, and we can start to institute ideas of computer programming, right? Where we're writing functions that we're reusing and things like that. All right, so hopefully that was a helpful video on how to use NumPy to do some calculations involving vector geometry.